So let us start with previous class, session 2. So we have installation modes of Hadoop. Okay, so as we discussed yesterday till last class, we discussed what is Hadoop, Hadoop theory part, everything we have discussed. Now installation modes of Hadoop. So we have these type of installation modes available in Hadoop. Okay, so standalone mode, pseudo distributed mode, fully distributed mode. Okay, so what is meant by standalone mode? All Hadoop services run in a single Java virtual machine, JVM, on a single machine, right? And pseudo distribution mode, individual Hadoop services run on an individual JVM but on a single machine. Okay, and also fully distributed mode. So Hadoop services runs in a different JVMs but in a cluster, more than one machine, called different servers. Okay, so let us see what is meant. Let me explain. Let me take a paint and explain. The first one is standalone, right? So for example, if you consider this is a Linux machine, okay, so for example, this is, if you can consider it is a Linux machine. Okay, so in the Linux machine, inside Linux machine, all services, Hadoop services will run on single machine within single JVM. For example, if you consider the out box, inner box is a JVM. Okay, so this is a JVM, Java virtual machine JVM, right? And here it will run on NameNode, data node, secondary NameNode, job tracker, task tracker. Okay, so let me write it one by one. Services names, NameNode, data node, secondary NameNode, job tracker, and task tracker. So each and every Hadoop services runs on single JVM and finally in a single machine is called as standalone. Okay, it is called as, what is that? Standalone mode. Standalone mode of installation. Yeah, this is standalone mode installation. Okay, so this is one standalone. It means all Hadoop services runs in a single JVM. If you can see it here, single JVM. What is meant by JVM? JVM is a, I can say here, to run a memory. To run a memory. So what is meant by memory? So for example, if you want to run any of the services, Java or Java programs, so it will run on memory, right? So it will use a container to run that programs. So here I can say JVM is a container. So for example, if I'll assign a virtual machine for 2 GB RAM or 3 GB RAM, within that 2 GB, 3 GB RAM, all Hadoop services will run. Okay, so we can see it here. For example, if I'll go to here, so if I'll open, so if I'll see, this is Oracle VirtualBox, this is a virtual machine. So here, this is my virtual machine, right? And you can see it here, I assigned a 2 GB RAM. So this is a container size is 2 GB. So inside that, and also this is single node cluster with same standalone. So here, if I'll start this one, all services will run on NameNode, data node, secondary NameNode, job tracker, task tracker. So everything will run on under this JVM only. This is called standalone installation. Okay, so let us go back. And also pseudo distribution mode. What is the pseudo distribution mode? Individual Hadoop services runs on an individual JVM but on a single machine. Okay, so this is also, we'll see in a separate paint. Okay, so just imagine this is a separate one Linux machine, again Linux machine, okay, and also sudo distribution mode, psedu sudo distribution mode of installation. Okay, so here separate JVMs. Okay, so one JVM, another JVM, another JVM, okay, another JVM, another JVM. 5 separate JVMs. Let me write it JVM details. JVM, 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 JVM. Okay, so and again each and every JVM one services will run on separately. NameNode, data node, secondary NameNode, job tracker, task tracker. Okay, so every JVM, every service will run on separate JVM. Data node, and I'll write it SNN, secondary name node. Okay, and here job tracker, right, and here task tracker, right. So each and every services runs on separate JVMs, but finally in a single machine, right, in a single machine. So for example, here you see this is Hadoop 2x installation, one machine, but here each and everything is a separate machine, virtual machines. So one virtual machine, another virtual, another. So every virtual machine is having separate memory, 2 GB, 2 GB, separate memory. So it means separate JVMs will use it, but finally in a single machine. So this is my laptop, right? So inside the laptop I am running virtual machines, separate JVMs to installing the Hadoop services on distribution mode, right? So that is sudo distribution mode. Okay, so let us last one, fully distribution mode. So what is this? We'll see. So fully distribution mode, we cannot able to see it here, since we have only to check that we need more than one machines. So this is one laptop, one server, Linux server, another Linux server, another Linux server, another Linux server, another Linux server, 5 servers. So 5 servers, Linux machine 1, Linux machine 2, Linux machine 3. These are physical machines. Linux machine 4, Linux machine 5. Right? So each and every Linux machine separate JVMs, and also each and every Linux machine there is one separate service, data node, name node, secondary name node, job tracker, task tracker. Okay, so if you can see it here, name node, data node, secondary name node, job tracker, task tracker, right? So it means individual machines are running in a cluster. Yeah, that is running on cluster. I can say it as a cluster. So this we can see it in only production when you joined a company. So you can see all these are these services will run on separate individual physical machines that we cannot see it here. So if you have more than one machine, maybe 4 laptops, 5 laptops, you can connect through a network and then we can practice. But generally we cannot do this one here. Okay, so this is third one, fully distributed mode. Okay, so let us next one. So now preparing a node for Hadoop cluster. So for the installation of Hadoop cluster, we need to prepare a node. Node in the term, node in Hadoop terminology, node means a server, physical server. Okay, so these are the some steps we need to prepare a node for Hadoop cluster to ready for Hadoop cluster. The points are to installation of Linux. So we have different Linux flavors. So based on the client requirement, so we need to install if you are a Linux admin also. Otherwise, if you're in your company, if there is a separate Linux team, they will install the Linux and they will hand over the machine to you. Okay, and install the OS. It's a Linux or Ubuntu, whatever it is, and disable the SE Linux and IPv6. And another important point is install Java. Why? Since all the programs, everything will run on JVM container, right? So Java is mandatory. Installation of Java is mandatory. And also Hadoop supporting software, it is required. So OpenSSH, Python, HTTP, NTPD, all are most important supporting software, Hadoop supporting software. Otherwise, it will not execute Hadoop. So we need to run it mandatory. Okay, right, let us. Then the next one is create. So if you want to go for the further process, so we need to create a Hadoop user and dedicated user and a group also. First we'll create a group and create a user, and then we have to do it as we have to add that user to the group. Okay, and also one more is configure disable firewall or open Hadoop ports. Okay, disable the firewall and open the Hadoop ports, and again configure the network DNS. Okay, right, and another is enable NTPD, network time protocol daemon, right, and configure. Then the last one is configure passwordless SSH from master to all slave nodes. Okay, right, and also another one is Hadoop manual installation steps. Okay, so what is this? Let us see. So manual Hadoop installation steps are, first step is Hadoop is open source. We will get it from the website. So download and extract Hadoop tar files. Okay, and configure the environment variables and configure Hadoop configuration files and copy the changes into all other nodes in the cluster. So cluster is, what is meant by cluster? More than multiple nodes is called a cluster, right? So cluster, and format the name node, only one time activity, start the Hadoop services, and we can start after the starting Hadoop services, check it whether everything is properly working or not, started or not, and then we can start the transferring the data, and then developer can start their analysis. That's it, Hadoop. Okay, let me go to the next slide. These are the important configuration files available in Hadoop. Okay, so what is the file name and the description? File name is hadoop-env.sh. So the file is description is like what they will do. Environment variables that are used to used in the scripts to run on Hadoop that can be used it. So we need to mention. And one more is core-site.xml file. So configuration settings for Hadoop core operations such as input output settings that are common to the HDFS and MapReduce. And third one is HDFS-site.xml configuration settings for Hadoop daemons. What are the daemons? NameNode, secondary NameNode, and data nodes called as daemons, Hadoop daemons. Okay, and MapRed-site.xml configuration settings for MapReduce daemons, job tracker, task tracker. That are all settings we need to implement or we need to configure in MapRed-site.xml. And another is masters. So a list of machines, one per line, that each runs on a secondary name node. We need to mention it here. And also slaves, a list of machines, one per line, that each run on a data node and task tracker we need to provide. And yarn-site.xml, and you can observe it, last 4 lines are mentioned with some stars. Stars means those are started from Hadoop 2x onwards, not 1x. 1x is not available, those last 4 files. Okay, and Hadoop 2x onwards, those has been implemented. So yarn-site.xml. So configuration settings for yarn daemon, resource manager, web app, proxy server, and node managers. Those details we need to configure it here. And also yarn-env.sh, environment variables that are used in the scripts to run yarn overrides the variable setting in Hadoop-env.sh. And log4j dot properties for system log files, NameNode, audit log, and tasks for the task JVM process, that we are going to mention it in the log4j properties. And Hadoop-policy.xml configuration settings for access control lists. It means like a security when running on Hadoop in a secure mode. That and all we need to mention it in Hadoop policy.xml files. And the above files available in star mark with started in Hadoop 2x onwards. It means those are not available in Hadoop 1x. Okay, these last 4 one. Fine, let us. So edge node, yesterday we discussed. So users, end users, developers, admins, anyone, we cannot able to connect directly through Hadoop cluster, right? So if you want to connect to the cluster, so we have to connect through edge node. So this is edge node and this is client, this is the cluster. So using edge node through we can connect to the cluster and we can get the data. So if there is no edge node, we cannot connect to the cluster directly. So in Hadoop terminology, so they'll call it as edge node, but by the companies they'll call it as management node or gateway node or application node. So different names are, they can call it whatever they want. Generally companies, they'll call it as application node, management node, or edge node. General terminology is edge node, but they'll call it as management node, edge node, or whatever it is. They can call it in the companies. Okay, and edge node is a node interface between Hadoop cluster and client applications, can be referred as gateway and application node. And also in the edge node, there is no Hadoop services will run, nothing Hadoop services. What are the Hadoop services? NameNode, data node, job tracker, task tracker. That will not run on edge node. Nothing will run. But what it will be available? So it will be running on some ecosystem tools. So we have some ecosystem tools like Hive, Pig, Scoop, HBase, Uzi. Those we can configure it. Okay, so it's up to client requirement. And also, so often used as a staging area for the data being transferred into Hadoop cluster. So if you want testing purpose. So if you want to testing some data, so you can configure this one and we can load the testing data into here. Then later you can transfer into production cluster or else testing cluster. Okay, staging, testing for testing purpose. So you can keep this in the node some data and later you can transfer it. And that is the history of edge node. Okay, and also what are the limitations of Hadoop 1x storage layer? So Hadoop 1x storage layer, we have seen name node, data node, secondary name node, right? Storage layer. So Hadoop 1x, we have single point of failure, name node. If name node goes down, so we cannot get the cluster will be down. We cannot get any of the operations. So we will not able to connect to the data. We will not able to get the whatever the data you want. We cannot get it. Since we don't have any other name node is the primary point of contact, and also only one node. All the metadata is available in name node, right? And even secondary name node available, that will never act as a name node, right? Only one name node. If that is failed, Hadoop cluster will be down in Hadoop 1x environment. Okay, and only manual intervention is required in case of name node failure. For example, if name node failure happened, so as a Hadoop administrator, we need to take one more machine, one more physical machine as a name node, and we need to configure it, and we need to take the backup copy from secondary name node, and then we need to place it in a new machine, and we need to start that machine as again cluster. So it is a manual intervention and it will take a lot of time. That is a drawback. Okay, and also only one copy of metadata available in entire cluster. So it means, so we have metadata will be available in name node and as well as secondary name node, one copy, right? So if name node goes down, that copy will be gone. We will lose the copy. So we have only one copy available metadata for the secondary name node, where it is secondary name node. If that is also gone case, any of the reason, so we will lose entire metadata. So it is a huge loss of the data. Even we have a data available in data nodes, but if metadata lost means we cannot able to trace the file names, file properties, right? It is useless. Okay, and also chances of losing data if checkpointing is not happened. If checkpointing is not happened on regular intervals, what will happen? We will lose the edit logs, right? And also the Hadoop 1x is limited to 4000 nodes per cluster. Okay, so it is only limited to 4000 nodes per cluster. Okay, so let us. Okay, and so to overcome the drawback, so they have introduced Apache Hadoop started with name node high availability from Hadoop 2x onwards. So this is Hadoop 2x architecture, one type of architecture. So instead of secondary name node, they started with one more name node called standby name node. And this is Hadoop 2x architecture, one type 1, first type. Okay, so this is active name node, standby name node, and here this is shared network drive, NFS drive in one machine in network file system where it is storing on metadata. So extra copy, one copy here, one copy here, one copy here, metadata copies. If these two goes down also, no problem, we have one more copy is available. That is what Hadoop 2x onwards, they have introduced a node called standby name node. So what is it means? Okay, so if active name node goes down, automatically standby will act as a name node, and then this will run, and then it should be running the client operations as it is in the Hadoop cluster. That is the standby name node duty. If active goes down, standby will work as a active name node. But how this will work? Here one disadvantage is how this will work. So there is no automatic mechanism. For example, if this goes down, it should not up automatically. This will need to start by someone. Who is that someone? Hadoop administrator. Hadoop administrator manually need to start the standby name node. If it is, for example, if Hadoop administrator not in a shift is in, so if it is night shift, for example, the active name node goes down. So what will happen until morning? Someone come to office, Hadoop admin, then the node will be on down status. Cluster will be on down status, right? That should not be the case. But here, someone need to start this one. Some Hadoop administrator manually we need to start. That's what a first scenario. It is not useful. Hadoop 2x architecture first type is not at all useful. Okay, but the introducer as standby name node, it will be working as an active name node if active goes down. Okay, then let us see one by one. Next one. So limitations of name node high availability. For example, if this is in this scenario, if this is goes down, so if you have some automatic mechanism here, so someone should automatically up this one within immediately fraction of seconds, then that will be good. So we will not lose any data. So we will not lose any of the operations. Client operations will continuously running on. So no problem for the cluster. That mechanism, automatic mechanism called as Zookeeper. We will see it. We will see it in Hadoop 2x architecture second type onwards. Okay, so let us discuss. Then, so let me take a paint. Okay, so before going to Zookeeper, let me draw it a picture of Hadoop 2x environment. Hadoop 2x architecture second type. Hadoop 2x architecture second type. It means name node high availability with Zookeeper and NFS, network file system. Okay, so let me try it. So we have a name node 1, active name node, standby name node. We have some data nodes, right? So all are connected, both the name nodes, like this way. So both the name nodes will connected all the data nodes. Okay, let me draw the name node, active name node, active name node, standby name node, right? And if I'll go to here, I'll mention it data node 1, data node 2, data node 3, data node 4, data node 5. Okay, so this is newly introduced on standby name node in Hadoop 2x onwards, right? And now the latest one, they implemented Zookeeper, right? So here are the Zookeepers. So group of Zookeepers, Zookeeper machine 1, Zookeeper 2, Zookeeper 3. Okay, and also two more components, Zookeeper failover controller. Okay, let me write it. Zookeeper failover controller. Same here. Zookeeper failover controller. Right. So this will call it as Zookeeper 1, Zookeeper 1, Zookeeper 2, Zookeeper 3. So this is called Zookeeper quorum. Okay, and also this will connect Zookeeper quorum like this way. Okay, and also one more is we have some network file system to storing the metadata, right? So this will connect both the name nodes. This is Hadoop 2x architecture second type NFS drive. Okay, so this is where we are in Hadoop 2x NameNode high availability with Zookeeper and network file system NFS drive. Okay, for example here, if some reason, okay, so if any of the, this is active NameNode, right? So if any of the reason this active goes down scenario, node failure scenario, what will happen? So it means it is not, if it is down means this will not send a heartbeat signal to this one Zookeeper failover controller. If there is no heartbeat signal received from the Zookeeper failover controller, this will inform to the Zookeeper quorum. So name node has been down. Please start other name node. So this will send the signal to Zookeeper failover controller. This will start the standby name node as a active within 3 seconds of time. Everything operations will be completed. Right? So that is the way it will work. So automatically will up. So no need of Hadoop administrator manual intervention required here. If active goes down, standby automatically will up if you are using Zookeeper mechanism. Okay, and also there is nothing cluster down and there is no user interruption on client operations, nothing will happen. Everything will running as it is. Okay. Fine. Okay, then let us go to, so then here how the zookeepers will work. So we have some theory part, and once that is done, we have one more is there, third type. Okay, or let us discuss with third type and then we can go to the zookeepers. So one more is third type, Hadoop 2x architecture with third type. So let me write it. Hadoop 2x architecture third type, and what is that? NameNode high availability with Zookeeper and journal nodes. So they introduced a new concept called journal nodes. Okay, so instead of NFS drive, they introduced a new nodes called journal nodes. Okay, we'll see that. What is that? What is the architecture? How it has been implemented? So again, we have some name node, active name node, standby name node, right? And data nodes, right? Data nodes, and everything connected as it is. Okay, so let me write it. Active name node, standby name node, and also data node 1, data node 2, data node 3, data node 4, data node 5, right? And again, the top there is a Zookeeper quorum, right? As it is 3 Zookeepers, Zookeeper 1, Zookeeper 2, Zookeeper 3, right? And same as it is here, ZKFS, Zookeeper failover controller, Zookeeper failover controller, right? Zookeeper failover controller and Zookeeper failover controller, right? So this will communicate with NameNode the same as it is. Okay, so till here, when you compare to previous one, what is there? Everything is same except NFS drive, right? So instead of NFS drive, here they implemented new nodes called journal nodes. Okay, so how it will be? So there has been implemented a new concept called journal nodes. Okay, so this journal node will sync with both the name nodes. Okay, and again 3 journal nodes, JN1, JN2, JN3. JN stands for journal node. JN1, JN2, JN3, journal nodes 3. Okay, so this has been implemented and each and every journal node will connect internally for syncing. Okay, and what is that? Why they have been introduced journal nodes here? If you see here, there is one copy of metadata, one copy, second copy, third copy. If for example, if both the name nodes are goes down for any of the reason, so we have only one more copy of metadata will be available. And if any network issues, that also will gone. So it means we will lose entire metadata copy. So to overcome that, they introduced journal nodes. Here, one copy of metadata active name node, another copy of metadata, and remaining 3 more journal nodes. Total 5 copies of metadata available if you are using Hadoop 2x architecture with name node high availability with Zookeeper and journal nodes. Right? So that will avoid to chances of faulty tolerance. So to avoid losing of metadata. That is what this is Hadoop 2x, 3 type of architectures. Architecture first type, second type, third type. So this is the one current one industry are using. Journal nodes with Zookeeper. Okay, so let me check. Then let us go back to the here. So as discussed here, now we have Zookeepers. What are the Zookeepers? What are Zookeepers and how it will be working on here? So Zookeeper is a highly available, highly reliable and faulty tolerance coordination services for distributed applications. Okay, and it will work on below scenarios. So ensemble, so group of Zookeepers nodes worked as a single unit rather than individual, and number of quorum, number of nodes that should be up and running in the ensemble, and number of node failures that can be tolerated in the ensemble will be rounded n by 2 comma 0 minus 1, where n is the number of total nodes in the ensemble. So Zookeepers ensemble, what is ensemble? If you see it here, so there is a Zookeeper, so we did not written right. There is a Zookeeper, Zookeeper 1, Zookeeper 2, Zookeeper 3. So these 3 are working as a group, right? So group, what is the group? ensemble, a group of Zookeeper nodes working as a single unit. These three are working as a single unit. Instead of working individual, these three are working as a group. Okay, and ensemble. What is ensemble? Ensemble is quorum. Quorum is number of nodes. Number of nodes means number of services in the group working fine, up and running fine. That is called as quorum. Okay, so and quorum can take a decision. Quorum means if three people, for example, if active name node goes down, so if Zookeeper quorum discussion, so Zookeeper failover controller informed name node is down, then Zookeeper quorum will discuss and decide within a fraction of seconds, and it will go to the standby name node and it will up automatically. That is the Zookeeper quorum work. And why odd number of nodes in Zookeepers? So Zookeeper ensemble of 5 nodes round 5 by 2 comma 0 minus 1 equal to 2 nodes. So if you take in a 5 nodes, 5 by 2 how much? 2.5. 2.5 minus 1, so we can consider it as 2. So still, if you have 3 nodes, 3 Zookeepers, 1 goes down means we have still 2 more. So 2 more is working as a group, and then they can take a decision and they'll work for the client requests. So it means cluster will up. And if it is 6 nodes also, no problem. 6 nodes also, if you take in 6 nodes also, round 6 by 2 comma 0 minus 1 equal to same value 2 will come, right? So there's a extra node nothing will help us. Just adding for benefit of the cluster, that's it. And so replicating that one extra node is just for a performance overhead. Other than that, nothing will happen. So we can go to Zookeeper odd numbers, either 3 or 5 or 7. Okay, instead of going even numbers. That is Zookeeper. And what is Znode? Zookeeper maintain an active session with all its clients using a heartbeat mechanism. Furthermore, Zookeeper keeps a session for each active client that is connected to it and assign a key which is called Znode. What are the types of Znode? So there are 3 types of Znodes. Persistent, basically a managed data bin. Ephemeral, exists for lifetime of its client session. And sequential, gets a unique sequence number when created. Okay, so generally we will use it sequential. Okay, right. So Zookeeper leader election. So we have 3 Zookeepers, right? But how it will be working? Those 3 are working as a group, but how it will be working? Who can give the instructions to work? So someone should give the instructions. That is what the idea came up here, as one is a leader, 2 others are followers in the Zookeeper quorum. Okay, if you see the diagram, the first one is a leader and remaining 2 are followers. Zookeeper 1, 2, 3. First one is leader. But how the first one will be a leader? The scenario here, when you start a Zookeepers in a cluster, right? So when you issue a command, start zookeeper.sh command, so all 3 Zookeepers will start at a time, but in a fraction of seconds of time, milliseconds of time. So one will be starting a first one. One will start at a first one. I mean, when the Zookeeper is started, there is a number will be initiated. Number will be assigned. That number is called Znode. So which one receives the least number of Znode is called as leader, marked as leader, automatically come into leader. So for example, when you are starting a Zookeeper, all 3 Zookeepers, so first one received, which we don't know, in a 3 Zookeeper nodes, for example, Zookeeper 3 received least number of Znode. It means this will become a leader. Remaining 2 are followers. That is the scenario here. Okay. And also, for example, if leader goes down, the next sequence will be acting as a leader. Other will be follower. That way it work. Okay, right. And what is the other one? Let me go back. So this is the latest one we have seen, right? Architecture. NameNode high availability with using Zookeeper and journal nodes. JN stands for journal nodes. So you can see it here: active NameNode, standby NameNode, data nodes, right? And we have Zookeeper failover controller, right? Same Zookeeper failover controller. It will send the heartbeat from NameNode to Zookeeper failover controller and then heartbeat to Zookeeper quorum. If heartbeat is missing from active NameNode, this will send the instructions to this, and this will standby NameNode will up automatically, right? So this is what latest architecture of Hadoop 2x third type. This is running on currently in the market industry. Okay, let us. So advantages of NameNode high availability with Zookeeper and journal node. What are the advantages? The main is multiple copies of edits for both the name nodes, and we can configure journal node as edits copy also, and high availability against hardware and network failures, and automatic failover to active node and standby using Zookeeper. So no need of manual, so everything will be automatic. If active goes down, standby will up. And after that, so as a Hadoop admin, we need to fix it. Then once that is fixed, automatically we need to start again after fixing the issue for the down node. Then it will start and it will move to standby. Again, then if name node primary goes to active goes down, the standby will up automatically. That is the cycle, chain cycle. Okay, that will never end, right? And also, what is meant by failover? The transition from name node to the standby, active to the standby, is called as transition. Failover. Transition happen means failover. Failover means, for example, if active goes down, standby should automatically up. That is called, the scenario is called as like the movement. When the movement of name node goes down, automatically standby should up. The process will call it as failover. Okay, and is managed by a new entity in the system called failover controller. There are various failover controllers, but default implementation is Zookeeper failover controller. Okay, so what is the true? Why? What is the reason? So Zookeeper failover controller is always maintain only one active name node in the cluster. If both are inactive, it means if both are trying to write the metadata, so metadata will be corrupting of a chance of metadata. It should not active. Both should not active. Both name nodes should not active in a Hadoop cluster. Only one name node active, another is standby. Okay, it means active name node and another is passive name node, passive node, something in terms of Windows terminology. Active server, passive server. Okay, only one should be active at a time. The same way here. So if, for example, if both name nodes are running, so it will chances of losing the corrupting of metadata. So in that time, Zookeeper failover controller will kill any one of the name node service, and then it will maintain only one name node will be up. That is Zookeeper failover controller duty. Okay, right. And graceful failover. Even as a Hadoop admin, we can do it for failover manually. Sometimes, for example, in the maintenance activity, or if you are going for any upgrades, we can do that manually. That is also available. So fencing. Fencing in case of ungraceful failover, however, it is impossible that to ensure that the failed name node has stopped running. Example, some of the scenarios, if any of the network issues, name node is still running, but some of the network issue, it is not sending the heartbeat to the Zookeeper failover controller. It means Zookeeper failover controller think that name node goes down. They think that it is down, and then they send a signal to the Zookeeper quorum, and Zookeeper quorum will automatically send the signal to another Zookeeper failover controller. Then standby name node will up automatically. But scenario here is active name node is still up and running, but some reason, network reason, it is not sending the heartbeat. So what will happen? That time both are trying to write the metadata, so metadata will be corrupting of a chance of corrupting. So to overcome that, fencing is a method to kill previous name node active session will kill it automatically using the fencing method. And SSH fencing is the method to kill the previous active name node process. So it means only one name node will be active on every time, not both. Okay, and what if we make both name nodes are active? What will happen? For example, if you keep it both the name nodes are active, what will happen? It means both both are trying to write the metadata, right? They think that both name nodes are in their controller of Hadoop cluster, and they both are trying to write the metadata, but somehow the files will be corrupt, metadata files, and entire Hadoop cluster metadata will be corrupted. It is useless, right? Then, so that is a split brain syndrome mechanism. Split brain syndrome, we'll call it as split brain syndrome issue. And Zookeeper failover control is the fencing concept. It will take care of automatically. So it will make sure that only one name node is active, other name node is standby in always. Okay, let us see. Right, so we have another some interesting points in Hadoop. Okay, so before going to that, we need to check the, okay, let us see a safe mode. So name node, safe mode is a mode which the cluster is read-only mode. So this is when checkpointing is done and it builds the block report bitmap. We cannot perform any operations when the name node, when the cluster is in safe mode. So when you are stopping, after stopping, for example, if you are going to start, so if you have more number of blocks available in the cluster, so full huge data, so that time name node will not start immediately, so it will wait until sufficient number of blocks will be reported from the data nodes. So till the time name node will maintain in a safe mode. Safe node means they will not allow write access. It means if the name node is in safe mode, if you try to copy some data from outside to Hadoop cluster, that will reject. So it means it will show mention like name node is in safe mode. So only read operations will be allowed. Write operations will not allow until the safe mode leaves. Okay, so these are the safe mode commands. Hadoop dfs admin -safe mode get to get the safe mode, and Hadoop dfs admin -safe mode enter to enter the safe mode. Hadoop dfs admin -safe mode leave to leave the safe mode. Hadoop dfs admin -safe mode wait. If you want to wait safe mode continuously some more time, but the default time is 5 minutes. Okay, and Hadoop dfs admin save namespace. This is called to perform checkpointing, manual checkpointing. And Hadoop secondary name node checkpoint, and Hadoop secondary name node checkpoint force checkpointing. Hadoop dfs admin metasave file name.txt. This is the metadata file storing in a text file. Okay, let us. So these are some basic commands in the Hadoop file system. But before this, going through this, so we'll install the cluster, okay, and we'll try to copy some data from outside to Hadoop, and then we can run these operations. Okay, that we can see it. Let us check. Okay, so we have the next concept is like we will create a single node cluster in Hadoop, and we'll install single node cluster in Hadoop, and then we can load some data from outside. Outside means Linux file system to Hadoop file system, and we'll verify the data, and we'll try to execute some sample job, and we can upgrade also. We can see the Hadoop version upgrade also, and we can conclude it. Okay, so let us, right? So let me check it here. Okay, so let me remove this one, and so I'll clone it for this one, clone it as master. This is virtual machine. So how to install Hadoop starting onwards, we'll see the next session. Okay, so let us wait until the cloning of the machine. I'm going to clone it a virtual machine, and once it is cloned, we'll change the IP address and we'll try to start the Hadoop 1x installation. Okay, let us wait for completion of this session. Let us wait to clone the machine. Virtual machine, it is cloning. This is Oracle virtual machine, so it means one of the Linux box. So we can install Hadoop in this Linux machine. Okay, right, let us